Right triangle trig application example number 3. You are at an unknown distance d from the base of the mountain. So in purple highlight, that's this distance here. As shown in the image, the angle of elevation at the top of the mountain is 65. So if you were standing out down below, you'd look up and you form an angle that's 65 degrees. You step back 100 feet and the measure of angle of elevation changes to be 60 degrees. Find the height of the mountain. So I see I have two unknowns. So anytime I have two unknowns, I should have two equations. So if I look at what I have here, I have two different right triangles. The distance for the first one that I highlighted being d. If I had to come up with an expression for the bottom leg of the larger triangle, it's d plus the distance that I stepped back, which is 100. So d plus 100, would that be that expression? Now, given that I have two variables, there has to be some relationship that joins h and d together. So if I'm standing at 65 degrees, my initial position, and I'm having to incorporate h and d into my trig function, I'm going to use tangent, because tangent of 65 would get me opposite over adjacent, or in other words, h over d. Similarly, if I use 60 degrees as my vantage point and I use tangent, I would get a relationship of opposite h over adjacent, which is d plus 100. Notice that in both of these equations, we have a common variable of h. So what I'm going to do, systems of equations, I'm going to solve for h, multiply both sides by d, or the denominator, d on the first fraction, and then d plus 100 on the second fraction. Notice that since now I have each one of these is equal to h, what I can do is use substitution and substitute in one of the expressions for h into the other equation. So I have tangent of 65 is equal to d plus 100 times tangent of 60 using substitution. Now this is just a constant value. I can take that constant value and distribute it to each one of these terms, because my goal is to isolate d, and I need d all to be on one side. So I have d tangent of 65 on this side equals d times tangent of 60 is d times tangent of 60 plus 100 times tangent of 60. You want to view tangent of 60 as just a constant. So you leave it alone for now. We have variables d and d on both sides of the equation. So what I'm going to do is subtract this d term over to the other side. And I get d tangent of 65 minus d tangent of 60 is equal to 100 tangent of 60. So over on the left, d is in both terms. So I'm going to factor out my GCF of d. And then what would I do to isolate d? Well, if d is separated from the other term by multiplication, I can divide both sides by that term. So d equals, numerator is 100 tangent of 60 all over tangent of 65 minus tangent of 60. If you were asked to leave things in calculator ready form, this would be your solution. Don't need to figure out what the answer is in terms of a decimal value. That would be your solution. That's your kind of simplified calculator ready form. However, if they asked for a decimal approximation, then if you entered that into your calculator, you should get a decimal approximation of 419.9, or to the nearest foot is what they were asking for. So d is 419.9. However, they wanted the height of the mountain. So 419.9 is simply d. So what we do is we go to our expression, which if you can look at what I'm highlighting, there's an expression for finding h. And for finding h, we would take our d value and times it by tangent of 65. So let's write that in pink here. So as our final step, we know d tangent of 65 is equal to h. So we're going to take the value that we have here, plug it into here, and solve for h. So h should be approximately, if you entered it into your calculator, 901 feet.